be discussing the paper, which is Physical Science Chemistry Paper 2, 2022. So let's start with the objectives. I'm not going to go through the instructions. You know exactly what you're supposed to do, but let me just emphasize on this. Sometimes when they give data sheets, some students leave the data sheet on the question paper, yet the data sheet which we are supposed to fill in, for example, a graph, and then they leave it in the question paper and they submit the answer sheet without that, for example, graph, which is supposed to be drawn, and then remove the paper from there, then attach it to the answer sheet. So please, if you find something like that, don't leave it in the question paper. Make sure that you tear it off and then include it in the answer sheet, because the answer sheet is the one which go for the marking or at the marking center, and then the question paper, they remain in your schools. Please don't leave the answer sheet or that extra paper which is supposed to be used from the question paper in your question paper. All right, let's start with the question 1. They're saying that which one of the following of the following has the lowest boiling point? So if you look at this, all of them are straight chains, and these are the same functional group, which is you see that they have the same functional group, same homologous series. Therefore, what is different is the number of carbon atoms. So if you look at this, they're saying which one of the following has the lowest. This is the key point, the lowest boiling point. Therefore, we look at a compound with a low number of carbon atoms. So the answer is going to be, because this one has 6, this one has 2, this one has 4, this one has 8. So it's this one which has the lowest number. So they're saying that when ethene is converted into ethane, the type of reaction is, so in this case, if you look at this double bond, so when this double bond break one of it, it means that it's going to create, so it's going to be CH3, as they have shown it here. But how does it come to this? It means that the double bond will receive one hydrogen, the bond here, from the double bond. It's going to break in the middle. One comes this side, another one comes that side. I mean the parts, and then this one is going to receive one hydrogen, and also this one is going to receive one hydrogen. That's why you count them 1 plus 2, which is 3, and then here 2 plus 1, which is 3. So it means that since we are adding hydrogen on the reaction, therefore the answer must be hydrogenation. Is there hydrogenation there? So the answer becomes D. 1.1.3. They're saying which one of the following compound is which one of the following compounds in solution will change the color of bromo methyl blue? So what do you look at this? Sorry. What are you looking at this? This is an indicator which detect the pH which is relatively equal to 7. But remember, it can be on the side of alkaline or the side of acid. So this indicator measures pH which is relatively acidic. So in this case, we will look at a compound which is having relatively weak hydrogen ions ionized, or the pH is a little bit higher, which is near to the pH of 7. So if you look at this one, no. This one is acidic. This one, no. This one, no. So the answer is going to become this. If you look at it, first of all, it's an organic compound. Therefore, its ionizing power is low. So it means that it does not dissociate completely when dissolved in water. So its pH is a little bit higher. So it is a weak acid. So the answer becomes B. Then they are saying 1.4, two different samples of impure calcium carbonate of equal mass react with 0.1 mole per decimeter cubed of sulfuric acid. Assume that the impurities do not react. So it means that you are scooping out the impurities. So what are they saying? The graph below shows the volume of carbon dioxide produced for each reaction. So if they are looking for each reaction, when compared to reaction 2, which one of the following statements best explain the curve obtained for reaction 1? So if you look at, before we go that far, you'll see that reaction 2 is faster than the reaction 1. This one is slow. This one is fast. Why? Because it's more to the left. The more it shifts to the left, the faster the reaction is going to be. So you'll find out that what are they saying here on the question? They're saying that the temperature is higher in reaction 1. No. The surface area is greater in reaction 2. It's a gas. The amount of impurities is greater in reaction 2. If the amount of impurity is greater, then reaction 2 would have been slower. The amount of impurity is greater in reaction 1. Yes, that's why it means that you have fewer number of particles reacting. Therefore, the reaction is a little bit slow. Hence, it shifts to the right. So the answer becomes D. Then they are saying that the equation below represents the hypothetical reaction, that is A plus B gives you C. You see that the enthalpy change is negative. If the enthalpy change is negative, what does it mean? The reaction is exothermic. The activation energy for the reverse reaction is a key point. They even put it in capital letters. Reaction is 110 kilojoules per mole. Which one of the following is the activation energy for the forward reaction? For the forward reaction, they are looking for the forward reaction, but they are saying the activation energy for the reverse reaction is this. Okay, let's try to describe this, because sometimes students tend to fail this question. So now, if the reaction starts from here, it goes up. For the exothermic reaction, the enthalpy, the products must be lower in terms of energy because heat has been released. And then they're saying that the enthalpy change is -50 for this reaction. So this is the beginning, and then this is the end. So remember, final minus initial. If this is final, this is initial. So this becomes 50, but negative because final is lower than the initial. So it means that this is a change in heat of this reaction shown here. But they're saying that reverse reaction is 110. So if this is remember this is activation energy, yeah, this amount is activation energy, and the species which is as activation complex. So it means that now if I'm reversing, what's going to happen here? So this one becomes the activation energy. You see? And they say that this activation energy for the reverse reaction, when the reaction is going that side, is 110, because I start from low and then I end up in high. Therefore, the activation energy is positive and the enthalpy must be positive. All right. Now, the question is asking, which one of the following is the activation energy for the forward reaction? So it means that the activation energy for forward reaction is going to be this, from here to there. So that's going to be the activation energy, whereby what am I going to do? So I have to subtract this from this. So if I have 110 minus 50, so what is the remaining balance? The answer becomes 60 kilojoules per mole. So I come here and I look for that 60. So it becomes B. So that is the activation energy for the forward reaction. Then question 1.6. What are they saying about question 1.6? They're saying that the reaction reaches equilibrium at 25 degrees C in a flask according to the following balanced equation. So this is the balanced equation. They're saying that which one of the following will change the color of the mixture from pink to blue? So if it is in equilibrium, and then now you have pink, then you have blue. For this reaction to change from pink to blue, what must be done? It means that something must be added here. Something must be added here, or something must be removed here. So if you add something here, it's going to favor the forward reaction. If you remove something here, still is going to favor the forward reaction. If you add something here, it's going to favor the reverse reaction. If you remove something here, it's going to, so that it feels that it must fill that space which you have created of removing. And then if you add here, it means that it's too much, there's too much or excess. It's supposed to be balanced, therefore favors the reverse reaction. So now let's look at this and we see. First one, adding water. No, water will not cause that a big change in color. Cooling the flask, cooling, this is the enthalpy change is greater than 0. So cooling of the flask. Now adding sodium hydroxide. Let me check and see. Adding sodium hydroxide will not cause this color to change. Then adding ammonium chloride. Do you have the chloride ions here? Yes. So if I add the chloride ions, because when ammonium chloride ionizes, it's gonna be ammonium chloride. It's gonna give me ammonium ion plus a chloride. So this chloride, it will be more here. When it's more there, what's going to happen? When it's more here, what's going to happen? It means that it's going to create a disturbance. And this disturbance is going to cause the reaction to shift to the right. And then the color will change from pink to blue. So the answer will become D. 1.7, they're saying that dilute nitric acid is added to distilled water at 25 degrees C. Okay, let me do like this. At 25 degrees C. Okay. Then they're saying that how will this affect the hydrozonium ion concentration and ionization constant, that is Kw, that is Kw means ionization constant for water. So at 25 degrees C. So they're saying how will this affect the hydrozonium ion concentration? Dilute nitric acid is added. Don't forget that this can only be changed by the temperature, not the concentration. Therefore, when it comes to you didn't change the temperature, you just added the concentration. Therefore, it means that it will remain, the Kw will remain constant, remain the same. So this could be the answer, and this could be the answer, because it remains the same. So this one becomes wrong, this one becomes wrong. But now, when you add dilute nitric acid, remember dilute nitric acid is like that. When it ionizes, it's a strong acid. It will give you hydrogen ions plus nitrate ions. So these are the ones, because it is dilute, so it's going to react to form the hydrozonium ions. So it means that the hydrozonium ion or concentration will increase. When it increases, but the Kw will remain the same. So this one becomes the most correct answer. 1.8, consider the ionization reaction 1 and 2. They're saying that when reaction 1 ionizes in water, it gives you this and this species, and the same species plus what? Plus water, it gives you species Y. So now what is species Y and what is species X? So remember, this is ionization. It means that it breaks down. So if it is like this, this is diprotic. It will ionize to give one hydrogen to the solution, and then that hydrogen is going to react with water to form this species, is going to ionize to give one hydrogen to, for example, like this, to the solution, and this hydrogen is going to react with water to form hydrozonium ion. That's why you have this hydrozonium ion here, then plus that species. Then it means that the species X is going to remain 1. Species X is going to remain 1. So if it remains 1, okay, let me show you what I'm saying. It's going to remain 1. So check, it was -1, but he has lost another hydrogen, so it becomes -2. These were 2 hydrogens. So if it loses another hydrogen, then it becomes -3. Before, it is phosphoric acid, is a triplotic acid. When it ionizes fast, yes, it loses the hydrogen, then plus Now 2, I have 2 here plus this. But now because it has lost 1 hydrogen, so it becomes a negative. That's why it looks like this. Now it ionizes again, ne? It gives out 1 hydrogen. So now it means that this is going to become 2, and then the number of hydrogens is going to become 1. And if it ionizes again, it's going to become this plus, now it's going to become -3. You see, it's -3. So basically, because I'm here on stage 2, this is going to be this species. So I come here, I look for that species. So I see this species here, I see this species. I see this species. So the answer is likely to be this, and this. But I say that when this X is brought here, it ionizes again. So when it ionizes, because it has been with 1 now it's going to become only this. So I look for this. Where is it? So the answer is this. Yes. So this one is also correct, but this was wiped out. Therefore, it becomes wrong. So the most correct answer here is A. So the answer becomes A. Then let's go to 1.9. 1.9. They're saying an electrical cell was set up using silver. Using mercury, not silver. Using mercury. And then the half cell and another half cell under the standard conditions. Don't forget that when you talk about the standard conditions, you must talk about 1 atmosphere. You must talk about 25 degrees C. Yes, and then you must talk about 1 mole per decimeter cubed. So, or 1 molar. So that's what they are saying. Which one of the following half cells, when connected to mercury, half cell will result in the highest potential? So it means that I have to look at which one is being oxidized more, the strongest reducing agent here. So I have to go to the scale, because here they're saying zinc. So let me say zinc, cobalt, and platinum, plus aluminium. So if I come here, zinc, cobalt, aluminium first. So it means that it's gonna give me the aluminium first. I think, yes. So it means that aluminium, zinc is here, then you find cobalt there. So it means that the other ones are down. So the most or the strongest reducing agent is gonna be aluminium. Therefore, when I come back here, I'll find out that A becomes the most correct answer. The following reaction takes place in electrochemical cell. Copper chloride gives you, that is in aqueous state, give you copper solid and copper plus chlorine gas. Now they are saying, which one of the following is correct for this cell? Copper chloride. Is it a galvanic cell? Not really. They are saying, why is it not a galvanic cell? Check the species this side. It's only 1 species. So this one can't be. Does it require the power source? Yes, because this is not spontaneous. It's not spontaneous. Reaction is, no, I've just talked about it. Copper acts as an oxidizing agent. Not really. So, let's look at it. Copper is up. See, copper is up and chloride is down. So copper is oxidized. Therefore, it becomes a reducing agent, because anything which is oxidized, it causes the other one to be reduced. Therefore, it becomes a reducing agent. So copper can't be an oxidizing agent. So the most correct answer is B, and then I will say that B is the most correct answer and the perfect answer. So we have managed to discuss about the first objectives, and we are sure that 20 marks can be obtained in a simple way. So use the same trick when you are writing your exam. Same trick, make sure that you pass. Yes. Don't forget to revise. Revise hard so that you don't regret in the paper. All right, let's go to question 2. Question 2 is about organic chemistry. They're saying that A2H in the table below represents the 8 organic compounds or molecules. Write down the letter of that represents compound that is. So before you start, you need to know to classify all of them. You have to know how to classify all of them. For the purpose of time, we might not classify them now. Let's go to the question straight. 2.1, which one is a keton? Which one is a keton? See, if you had declassified them, you'd have known them very fast. So keton, no, alkene, no, aldehydes. Keton is here. So the answer is going to be E. They have the general formula of this. This is the alkynes. Don't forget that alkane is plus 2, alkene is 0, and then alkyne minus 2, meaning that CnH2n plus 2, alkane, CnH2n, nothing you add, and then Cn, that is alkene, CnH2n minus 2, which is alkyne. And then if you come back here, it will give you the same thing, which is indicated there. So basically, let's look at this general formula now. They are saying kind, no, yin. That word yin. Remember the naming, it ends with yin. So F becomes the correct answer. Isomer of 2-methyl-butene. Isomer of 2-methyl-butene. So how many? This is the alkene. So it could be this. It could be this. Yeah, it could be this or it could be this. But now, how many carbon atoms are here? 2-methyl. Meth is 1 carbon atom. But is 4. So this is 1 carbon atom. This is 4 carbon atoms. So it gives us 5. If you count here, 1, 2, 3, 4. No, so that one's out. This is pent. Pent means 5. So 5 carbon atom, 5 carbon atom, and then same alkene. Also here it is the alkene. Therefore, the answer becomes C. The answer becomes C. Then it has the same molecular formula, as ethyl ethanoate. Ethyl ethanoate. Has the same molecular formula as ethyl ethanoate. So ethyl ethanoate, you find out that the answer becomes this. Why? Why this? Because ethyl ethanoate, sorry for that, ethyl ethanoate is an ester. And then this is a carboxylic acid. Therefore, it is a functional isomer. Is the functional isomer. And if you look at this, ethyl, it means 2 carbon atoms, and then this one, eth also means 2. So 2 carbon atoms, which is 4. And then here, 1, 2, 3, 4. 4 carbon atoms. So they have the same number of carbon atoms. And ethanoate, it means that it has OO, 2 oxygens. And then also here, it has 2 oxygens. So basically, that becomes the answer. So the answer here is going to be H. They're saying that question 2.2, write down the IPAC name of compound A. Compound A. Now, if you go back and you look for compound A, IPAC name of compound A. So let's look at the longest chain. The longest chain is 1, 2, 3, 4, 5, 6. Ne? Single bond throughout. Yes. So it's 1, 2, 3, 4, 5, 6. So it's going to become hexane. Ne? 56. Let me do like this. It's going to be hexane. Hexane. Yes. If it's hexane, what is the 1, 2, 3, 4? Those are branches, but we're going to make this as a functional group. So it's 1, 2. So it's going to be 2 bromo 1, 2 dash 2 1, 2 1, 2, 3, 4 comma 4 1, 2, 3, 4, 5 comma 5. Yes. Try methyl, because all of them they have 1 carbon atom. Trimethyl hexane. It's going to be 2 bromo. B comes before M. So therefore 2 bromo 2, 4, 5 trimethyl hexane. It's one word, ne? Yes. So that becomes the answer for that. Then they're saying that compound D, structure formula for F. What is the structure formula for F? So we go back here and look for the structure formula for F. So the structure formula for F is going to be, members, make sure that you write the structure formula. You write the structure formula. Because some people, they just write. And then some bonds are not shown. You end up losing everything there. So it is how many? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. but the double bond is on carbon atom number 2. 1, 2. Let me say 1, 2. So it is on carbon atom number 2, but the methyls are on carbon atom number 4. 1, 2, 3, 4. So there are 2 methyls. So when I have a carbon atom here, so this is a methyl. So I put hydrogens. Make sure that the bonds are 4 on each carbon atom. 1, 2, 3. So there's another bond, and you put the hydrogens in now. Don't leave it hanging, because when you leave it hanging, you lose a mark. You lose a mark. It is easy to lose a mark than getting a mark. It's not easy to get a mark, but it's very easy to lose that mark. So it is 1, 2, 3, 4, 5, which means spent, and then they're saying yin to in. Oh, it is yin, not in. So it means a small mistake has been done. Then this one goes out. Yes, so it becomes a triple bond. A triple bond. Yes, so it is 1, 1, 2, 3, 4, 5. Yes, which is pent. 2 is carbon atom number 2, and then yin is triple bond, and then they're saying that 4, 4, 4, 4, because this is the main what? The main the functional group, therefore it takes that direction. 4, 4, 4, 4. But what is this 4, 4 about? It is a methyl, hence I have these 2. So basically that is it. Let's go to question 2.3. 2.3. They're saying the homologous series to which it belongs. Compound D, write down, yes. So it means that we need to see the homologous series to which compound D belongs. So if you look at this compound D is an aldehyde. So it belongs to a homologous series aldehydes. And its functional group is formyl. It could be formyl or carbonyl. So it is formyl. Let me go back to my color. Yes. So they're saying that, so the answer becomes here, homologous series, it is an aldehyde, while this one is the formyl or carbonyl. Then 2.33 is going to become the structural formula of its functional isomer. The structural formula of its functional isomer. So it means that if this is a keton, if this is a aldehyde, therefore it's going to become the keton. 1, 2, 3, 4. So it means that we just have to put structural formula. Yes, structural formula of its functional isomer. So it means that they are going to be 1, 2, 3, 4. So I put there, and then I put the hydrogens. 1, 2, 3, 4. You see, I have to count and see if all of them are what? Are 4. So it's going to become 1, 2, 3, 4. Yes, this one is correct. 1, 2, 3, 4. This is correct. 1, 2, 3, 4. This is correct. 1, 2, 3, 4. Yes. So it means that that's the structural formula for that functional isomer. Then they're saying write the balanced equation using the formula for its complete combustion. Oh, no. Yes, I think I skipped. Yes, compound G, write down the IUPAC name of its chain isomer. IUPAC name for its chain isomer, compound G. G is butane. So what is the IUPAC name of its C chain isomer? So it means that I just have to change or to create a branch. So it could be butane is 4, so I have to make it 3. What am I saying? This is what I'm saying. 1, 2, 3, 4. So it's like that. It's a straight chain. But now I have to bring this here. So it is going to become 1, 2, 3, then a branch. Then I put the hydrogens there. But this is not the answer. They are saying the IUPAC name. Therefore, it's going to become 2-methyl. 2-methyl. Yes, 2-methyl propane. Propane. So it's going to become 2-methyl propane. 1, 2, 3, which is propane. Propane. Yes, and then the branch is on common atom number 2. Then balanced equation using the molecular formula for its complete combustion. So whenever they talk about combustion, your answer must add oxygen there. So that is the first answer you need to know, that it must add, and you leave space for balancing. It must add the what? The oxygen there. So now let's count it. Even if you use the other one or this one is the same thing. 1, 2, 3, 4. So it's gonna be C4. Yes. How many hydrogens? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the hydrogen is gonna be hydrogen 10 plus oxygen. That is the combustion which is happening, and then it gives you always the product is the same when you do combustion with the hydrocarbons is carbon dioxide plus water. So that's always the answer. So now you need to balance. If I put a 2 here, this is 8. So I put 8 here. Yeah, because this 2 times 4 is 8. So here is going to be carbon atom is 8. Isn't it? So now, if that is 8, so what about the hydrogens? Hydrogens, this and this and this is 20. 20, I have 10. I have 2 here. If I put a 10 here, so it's going to become 20. Now the problem is oxygen. How many oxygen do I have this side? I have 10. This is 16. It's 26. 26. 26. Is it 26? Yes, it's 26. 16? No. This 16 plus this is 26. So 26 divided by 2 is 13. So I'm going to put a 13 here, because 13 times 2 is 26. So yeah, I think it's balanced. Yeah. So this is a liquid, this is a gas, it's a gas, and this is a gas. Yeah, things balanced. Yeah. So basically, if the balancing is a problem, don't waste too much time there. Né? You can first write the equation plus oxygen, whatever they ask you, the carbon compound give you, plus oxygen, you're gonna give the same product, which is carbon dioxide plus water. That's always when you burn hydrocarbon in air. So that's the product you are supposed to get. Please don't forget that. So when you finish, you go back and try to come back here and then you balance, because it might take your time before you complete the what? The paper. The last question, but not the least, on organic compound, or the second question. They're saying that define the boiling point. When talk about the boiling point, you're talking about the point at which the vapor pressure of a compound in a closed system is equal to the atmospheric pressure. Yes, the vapor pressure must be equal to the atmospheric pressure. So then that's when the boiling point, that's when the boiling point is what? Is reached. Sorry. Then they're saying that the boiling point of compound A, B, C are compared. Now they're saying A, B, and C. Check. Propane, butane, pentane. 3, 4, 5. Correct. It means that there's a good comparison there. How do the boiling point vary? A to C. How do they vary? A to A, B, C. The boiling point is increasing. Then they are saying, give a reason for your answer. Yes. If they don't ask you why do they vary? It's because of the increase in the number of carbon atoms. So the intermolecular forces of attraction increases, therefore they require more force to be, more heat to break those bonds. And if you look at this, you'll find out that there is the London forces here. Yes. Okay. Then let's say, how do boiling point vary from A to D? A to compound C. A to compound C. We have seen it. Choose increase, decrease, or so we have said it increases. Explain your answer. You have given the answer there already, that it increases because of the increase in the number of carbon atoms, and then it increases the intermolecular forces of attraction. Yeah, the molecular forces of attraction increase the random forces, yes? And then this will require more heat to break these forces. Hence, the boiling point increases. The boiling point of B, C, and D are compared. Let's see. B, let me change the color. Someone saying, why that color? Okay. B, C, and D. Is this a fair comparison? Let's check. This is 3. This is 4. Yeah. Why that's car is, you are correct. Let me use this. This is 4. This is 5. Butane. Methyl is 1 plus 4, which is 5. See, this is 5. So the number is not changing, but straight branched. Yet also the mass is also changing here. So we have 2 independent variables changing. So the answer becomes no. Is this a fair? It's not fair. Why? Because 2 independent variables, 2 factors are changing. So we want to know what caused what. So therefore, no. Give a reason for your answer, because 2 factors are changing. That is the nature of the chain. This one is straight chain, and then the other one is branched. This one is branched.